So today we're going to talk about identifying proportional relationships. Does anyone remember what a proportional relationship is from last week? We talked about proportions. Okay, so that is an equivalent ratio, and I do need you to write this down. A proportional relationship is talking about an equivalent ratio, and that's kind of like another way of saying it's equal. And we'll look into exactly what that means a little bit more. First kinds of questions you're going to come across are going to tell whether ratios form a proportion or not. We talked about a proportion. That's saying that this is equal to this. Okay? There's a couple different ways you can go about it to figure it out. I'm going to show you one right now, and that would be by finding what's called the constant of proportionality, and essentially that's just telling me to divide. So what it means is if 7 divided by 2, if that's equal to 16 divided by 6, then yes, this is proportional. If it's not, then no, they're not proportional. So we'll use the calculator, or if you don't need to, does anybody know what 7 divided by 2 is? Lucas? 3.5. And then over here, we're going to try 16, because this fraction bar tells me to divide. 16 divided by 6. Okay, so we'll round it and say 2.67. So if I look at these here would be considered my constant of proportionalities, and you can see that they're not the same. So the answer for this would be no, they're not equal. They are not proportional, they are not equal. That's what that's saying. So the answer is no because of this. And I would be expecting you guys to write out what you're typing in the calculator. Showing me this equals 2.67, this equals 3.5. They're not equal to each other. Number 2, how would we set that up? Go ahead. 2 divided by 5, and then 16 divided by 45. Very good. 2 divided by 5, that's one that people might have memorized. Alexis? 0.4, good. 16 divided by 45, maybe you want a calculator for that. Go ahead. 0.35, repeating it sounds like. So it would be going on forever. Yep. The calculator rounded it. So looking here, proportional or not? But they're not exactly the same. If they're proportional, they will be exactly the same. Okay? So this one would be a no. Now with number 3, this is comparing 2 to 4.5, or 2 divided by 4.5 versus 3/4 divided by 3/10. 2 different ways you could do this, and we can do it whatever way you guys would prefer. You could just do out these division problems. You know how to do that. Or we could change them to decimals and use the calculator. What would you rather do? You want to do fraction division, or we want to do decimal division, I guess?
Fraction. Decimal.
Well, okay, does anybody know what 4/5 is as a decimal? 0.8. So this would become 2 divided by 0.8. And anybody know what 3/4 is as a decimal? 3/4 as a decimal. Yeah. 0.75, and she's carrying you guys right now, fellas. And 3/10, what is that as a decimal? 0.3, right? Still 3/10. 0.75 divided by 0.3 gives me 2.5, where 2 divided by 0.8 gives me 2.5. So you can see these are exactly the same. So then that would be yes, these are proportional. That's the first kind of problem that you're going to see when it's asking if it's proportional, and there's going to be one like that on your test. Yes, sir?
I have a question.
Okay.
With the decimals, how did it end up as a 2.5?
Because 0.8 goes into 2.5 times.
No, the other one.
0.3, well, 0.3 and 0.3 is 0.6. And then half of 0.3 would be 0.15. 0.6 plus 0.15 gets me there. This is going to go into there 2.5 times. Because it's like 75 cents and I have 30 cents. How many 30 cents? 30 cents can go into there 2.5 times. The other kind is similar to what we've done in the past. You're going to find the unit rate. Hey, knock it off. You're going to find the unit rate. So I'd want to know the calories per serving for both of them. We did this like with the better buy questions. This is the same exact idea. I compare this versus this and see, are they the same? Well, calories, 440, divided by the servings. And then 300 divided by 3. You said the first one was what? 110 calories per serving. 300 divided by 3. 100. So, are they proportional? If this one has 110 calories per serving, this one has 100 calories per serving, are they proportional? Are they equivalent? That's what it's asking you. No, they are not. And anytime you're doing this, you should show your work like this so that I can tell you're not just randomly guessing yes or no. If you just put yes or no, you will not get credit for it. The next one, we'd want to know the dollars per lawn, right? Compare that. So 45 is my dollars and 180 is my dollars. Per tells me to divide. There's 3 lawns versus 12 lawns. The first one you said is $15. And the next one? Ava? $15. Are they proportional? Are they equivalent? Yes. So you can see this is just picking up where we left off on the last things. These tables are just like the tables that you guys looked at before. Except before, I told you that they were all equivalent, and now you have to figure out, are they all equivalent? Are they all proportional? Well, I could do, if this is my x and this is my y, I could do the y divided by the x, or I could just see if I see a pattern here. This division, 2 divided by 6, well, that's going to be 0.3. 3 divided by 9, that's going to be 0.3. 8 divided by 24, that's going to be 0.3. 1 divided by 3, that's going to be 0.3. I could do it like this, the division. Again, with all of these, the division is always going to work. It is always, always, always going to work. But sometimes you're going to be able to just see a pattern. If you guys look here, if I go from here to here, that's 1 times 3. 8 times 3. 3 times 3. 2 times 3. So they're all times 3s. So they are, yes, this is proportional. Thank you. Just sit down for now. You're fine. With this one, if I look, this is 2 times 5, 6 times 2, 8 times 2, 12 times I don't know. Would this one be proportional? Well, is it always the same number? 2 times 5.
10.
Well, okay, I'm saying like this. Let's try this out. 10 divided by 2 is 5. 12 divided by 6 is 2. right? I could stop right there. You're right. I could stop. Noticed right away that they're not all the same. So this one is no. That means that the snow didn't fall at a constant rate. It changed throughout the day. As time passed, initially the first 2 hours were crazy. It was getting 5 inches every hour. But then it slowed down and the average became 2 inches every hour instead. So that's what it's saying. If the snow didn't fall at a constant rate, it's not proportional. This is the same exact idea. My recommendation here, I started off with 2 gallons, got me 54 miles. So I would want to figure out, what does 1 gallon get me? What does 1 gallon get me? 2 or 54, what would 1 gallon get me? What? 27. So that means every single gallon of gas could get me 27 miles. So to figure this out, I'd do 4 times 27. To figure this out, I'd do 189 divided by 27, because I'm taking this miles and I'm breaking it up in groups of 27. That's going to tell me how many hours. And this is actually going to be 7. I know it looks like it could be 6, but 189 divided by 27 is 7 hours. This would be 10 times 27 would be 270 here. Then I'd do 12 times 27 to get that blank. So every single hour is, every single gallon is 27 miles. This is just like the problems we did on the last test as well. 2 more kinds of problems I want to look at. One would be with graphs. Okay, with graphs, you need to have 2 things. It must be a straight line. And you need to put this down so you have this for your reference. And the second thing is it has to go through the point 0, 0. Remember, the first is your x. This is my x. And this is my y. So the x has to be 0 when the y is 0. Well, if I'm looking at both of these examples, they're both straight lines. As you can see, there's not any curves or anything in them. So they do pass that point, the first thing. But do they both pass through 0, 0, or do they both start at 0, 0? Yes. Well, 0, 0 is right here. So this one is definitely yes. This one doesn't start at 0, 0. It starts at 0, 10 is this point right here. So this one would have to be no. It is straight, but it doesn't start at 0, 0. 0, 0 would be starting right there. And then the last thing that I want you guys to look at is when we do with equations. Equations, keeping in mind that all of these lines need to go through 0, 0. So they're going to have no extra stuff. And I know that's not, mathematically how you would say it, but there's no extra stuff, meaning there's no constants afterwards. So something like this here, this is not proportional, because if I made an XY chart and I put 0 in for x, 0 plus 2 would be what? 2. So that means if x was 0, y would be 2. And we need it to be at 0, 0. Where if I did something like this that doesn't have any extra stuff, this is going to be yes, because if I made an XY chart and I put 0 in for x, that's 3 times 0 is what? 0. So it's going to be at 0, 0. You could always make this chart out, but I'm telling you, anytime there's extra stuff with it, it's not going to be proportional, because it means when I put 0 in, it's not going to start at 0 for y. It's going to start at a different number. So 13, is that a yes or a no? Is it proportional or not proportional? 13.
Oh, no. It would be that plus 8.
There's extra stuff, right? So this is no. What about 15?